go there. All right, let's finish up the algebra section, adding and subtracting rational functions or expressions. Sorry, no functions, just expressions. Remember to add and subtract them. We're thinking I need a common denominator. So I want to have the same denominator in both so I can put the numerators together. If I look at this first one, I'm looking at the first term needs an x, right? So I'm going to multiply. Let's write it down here. So I'm going to do a 3 times a 16x plus a 5 times a 24x squared. So I'm looking for a common denominator. One of the things I know is that I'm going to need an x in the denominator over here. That gives me the x squared, right? Now the 16 and the 24, both of those are divisible by 8. So thinking of common things between them, let's see. 32 would be the next biggest one for 16, but I don't see that working for 24. So let's go to times 3 would give me a 48 here, and I'm going to multiply this one by a 2. Okay? So multiplying all those together in the first term, I get a 9x over a 48x squared plus a 10 over 48x squared. And now I'm going to put the two fractions together, and so I'm going to get a 9x plus 10 over a 48x squared. Now, no matter what you want to do, do not cross out that x with the 9 with the x squared in the denominator. There would have to be an x in every single term in the numerator in order to do that. So this is it. This is as good as it gets. All right, so that's my answer. All right, hopefully that's good. Next thing, slope of a line. So if we're looking for the slope of the line formed by 2 points, remember m is equal to y2 minus y1 over x2 minus x1. The thing you want to watch for here is that all my x2s are lined up, all my second points are lined up, x2, y2, and all of my first points, y1, x1, are lined up. So I like to label them. So this is my x1, this is my y1, this is my x2, this is my y2. You can do it in the other order, and you'll get the exact same answer. All right, so I'm looking for the slope for the line formed by the points -4, -1, and 3, -6. So what we're going to do is we're going to say y is equal to, you'll see me write it as a delta y over delta x sometimes. It just means change in y over change in x. y2 minus y1 over x2 minus x1. So subbing in, my y2 is a -6 minus, here a -1, be careful. My x2 is a 3 minus a -4. All right, so I'm looking at my point, here, bring this, my point -4, -1 is lined up. My point 3, -6 is lined up. So I did it in the right order. So let's take a look. These two negatives make a positive, and these two negatives make a positive. Makes life easier. I get a -6 plus 1, that's a -5. Over a 3 plus 4, that's a 7. So I get a -5/7. Right, in a second, we're going to use this. You'll notice that the point in the next one's the same. Writing equations for lines, we can either use y equals mx plus b, or our point slope form of y minus y1 equals m times x minus x1. If I want it in point slope form, a lot of times I'll start with the y equals mx plus b, but this point slope form is really grown on me over the years. You can pick either one of the points to use for the x1, y1, but I'm going to keep them the same, x1, y1. Notice my points are exactly the same as above, so I already know that m is equal to, I don't know why there's a parentheses, a -5/7. So I'm going to use the second. I'm going to say y minus my y1 is So negative 1 equals negative 5/7 times x minus a negative 4. There's some ugly fractions going on here. I get a y plus a 1 is equal to negative 5/7 x. These two here made a positive, but now I'm multiplying it by that negative 5/7, so I'm going to get a negative 5 times 4 is 27. All right. If I want it in or slope-intercept form, I would move that 1 over to the other side and subtract it. If you want it in the standard form, what I'm going to do, I'm going to multiply everything by a 7, just to get rid of that fraction. All right, so both sides get multiplied by a 7. Actually, let's make it a negative 7, just so that we get rid of some of the negative signs too. All right, so what I'm going to get is, I'm going to go this way. I'm going to get a negative 7y minus 7 equals, as I distribute into here, right, I'm going to get just a positive 5x plus a 20. All right, let's put everything on one side. Since I have all the negatives over there by the y's, I'm going to add both of those and move it to the other side. I'm going to get a 0 is equal to a 5x plus a 7y plus a 27. Beautiful, huh? That would be my standard form. If you wanted to go for point or slope-intercept, then we would have subtracted the 1 over by the y and moved it to the other side. All right. Let's see, parallel and perpendicular lines. This is the last thing I'm going to cover in algebra review. Remember, if I have a parallel line, that means that M1 is equal to M2. My slopes are the same for both lines. I just likely have different intercepts, but I don't necessarily have to. Sometimes they're the same line. For perpendicular lines, remember that M2 is equal to negative of 1 over M1. So the slope of my first line, what I'm doing is I'm saying the slope of my second line is equal to negative of the reciprocal of my first. All right. So let's take a look. The example here determine whether the pair of lines are parallel, perpendicular, or neither. So the whole point here, if I don't meet either of these conditions, then I'm neither, is I need to find the slopes. So let's get them in slope-intercept form. I'm going to solve for y. So I'm going to get negative 5y equals, I'm subtracting the negative 15x minus 4. That means that y, dividing everything by negative 5, is equal to 3x plus 4/5. Right? So I divided everything here in between these by a little 5. Right? There you go. Actually, a negative 1. There you go. All right, so my slope here, this is my M1. M1 equals 3. All right? Let's take a look at the other one. Here, I'm going to say 3y equals negative x plus 9. Now, I'm going to divide everything by the 3 and separate it out. I'm going to get y is equal to negative 1/3 x plus a 3. So in this case, remember this was my slope right here. In this case, my slope is negative 1/3, so M2 equals negative 1/3. And you can see that's the negative reciprocal of M1, so these lines are perpendicular. Right? If they were parallel, they would have the same slope. If one was, let's say, 3 and the other one was negative 3, they would be neither. All right? So that ends the review for the algebra. We only have a little bit of trigonometry review. It's just really short. I think, oh no, I guess it goes a page and a half. So I'll do the trigonometry one separately, but this should take care of your parallel and perpendicular lines and help with that review. And then we'll talk about the trig one in some other videos. I'll talk to you soon. I hope you have a great time.